In bearings, we'll cover the bearing size, the material, and whether or not you need a race or non-race bearing. Next, we're going to move on to engine bearings. The first topic is going to be the size. If you recall back to the piston chapter, we talked about clearances. Well, the bearing clearances in your engine is something you need to be in control of because they're highly important. Bearing clearance is something that you want to be setting and not something that you just end up with whatever you get. The bearings are placed in your engine between the crankshaft and the block and the crankshaft and the rods. The bearings are a cylindrical shape made out of a material that is softer than your block, crank, and rods. Their job is to provide an oiled surface for the spinning parts to ride on and not touch each other. Your engine bearings are a wear item, and the idea is that you'll replace the bearings without having to replace the more expensive items like your block, crank, and rods. As you may have noticed, engine bearings come in different sizes, even from the same manufacturer. There are thinner bearings that will allow more oil to flow between the spinning surfaces, and thicker bearings that will allow less oil to flow between the spinning surfaces. The specific amount of oil between the spinning surfaces is important because you don't want those spinning surfaces to ever contact each other. Too much oil clearance, you'll have a problem, and too little oil clearance, you'll have a problem. So either way, you can experience an engine failure if you don't have the correct oil clearance. So the reason that the engine bearing manufacturers offer us the opportunity to purchase different size bearings is so that your engine builder can either provide you with a situation where there's more oil between the spinning surfaces or less oil between the spinning surfaces. There are two scenarios that would call for a non-standard size engine bearing. Either you've had material removed from your crankshaft or you're altering the size of the bearings to alter bearing clearance. The first scenario is if you have to machine the crank. Just like the block and the pistons, the crank and the block have a relationship that over time can develop imperfections. And the way to remove these imperfections is to machine the crankshaft down to a smaller size, requiring a thicker bearing. Just like the piston bore conversation, your crankshaft will be serviced in different size increments if it needs to be turned. So there's a 10 thousandths, 20 thousandths, 30 thousandths, and so on incremental bearing set available for specific engines. And this would allow the machine shop to take the minimum amount needed to get your crankshaft back to a proper surface. The other scenario that you would use a non-standard size bearing is if you were making an alteration to change bearing clearance. There are bearings available that are going to be 1/1000th of an inch different. So you may get a 1/1000th of an inch thinner or 1/1000th of an inch thicker. And this is basically so you can tune the oil clearance. There are engine builders that will use split sets, which will have a HX bearing on one side of the crankshaft and an H bearing on the other side of the crankshaft. And this allows the engine builder to work in very, very small measurements, much thinner than even a human hair. Because the size difference is so small in this family of bearing, they don't require machining. So to recap, if you're dealing with an engine that has a damaged crankshaft and instead of replacing it, you'd like to have it machined, you'll end up with a thicker than stock bearing to make up the difference that's removed to make the crankshafts correct again. If you're working on an engine that the crankshaft has not been damaged, you can likely just get away with having the crank polished. Then you can decide on whether or not you want to get a bearing that is 1/1000th thinner, 1/1000th thicker, or the standard size. For me, whenever I'm building an engine, I'll generally grab a set of H and HX bearings, which allows me to step in between the thousandths increment. So if I have a target rod bearing clearance of 0.0025 inches and I want to move it to 0.003 inches, I can just move from a split set of H and HX on one journal to an HX size, and then I'll get the desired clearance I'm looking for. Next, we'll talk about bearing material. There are a couple different options on the market, but the manufacturers keep it simple. You either have a race or a non-race bearing available for you. If you're not terribly interested in learning about metallurgy, just keep in mind the bearings are softer than the block, crank, and the rods. So if something's going to wear, it's going to be the less expensive part to replace. Race bearings are usually composed of 3 different metals and are usually softer than non-race bearings. Non-race bearings are 2 layers and are generally harder than race bearings. The harder non-race bearing is designed to be used in a factory application where the engine is to live hundreds of thousands of miles. However, this harder bearing is not nearly as forgiving in a race application where metal-on-metal contact is likely to occur. This segment is just a piece of the Real Street Bottom End Buyer's Guide. The full-length version can be viewed on our website by clicking the link below.